All right, guys, I think we'll be starting now. All good. All good. All right, we're all full, ready to learn. All right, Ashwin?
Yes, thank you. Hello everyone. We'll be starting the second talk in this series, and basically today what we're going to be doing is Hello Near. So we're going to be going over a very basic Hello World project for the Near blockchain. I'll be talking a little bit about Rust, some very basic Rust syntax, how everything ties together, and how you can read from and write to the Near blockchain. Um, so yeah, this is what I just explained. Um, but yeah, before I move on, out of curiosity, how many of you have experience in Rust? If you could, quick show of hands, like if you've written Rust at all. Okay, that's great because I'm teaching you everything you need to know. Um, cool. So getting started, there's this tool called Create Near App. So you don't need to do this now, but if you're making your own Near blockchain app, you could just do Create Near App and give it the project name. Say you want to use Rust for the contracts, and you can, like here, it says front end none. You can also do front end React. And if you're familiar with web dev at all, you can use React as a framework for your web dev. But today we're going to be using Gitpod to make things faster and easier. So what's going to happen is there's going to be a link which you guys can go on that link and it'll essentially clone the thing and give it to you. But we'll be doing that later. So moving on, I'm just going to talk about some very basic Rust stuff. So let's go to the playground. Um, okay. Um, can everyone see this? Nice. So we have a main function here, and let's do some very basic stuff, right? So first of all, how do you declare a variable in Rust? You do let. So you can do let x equals 0. That declares a new variable called x, which is initialized to 0. You can also do let x and x equals 0. But what you cannot do is this, because then it'll take then it basically won't know that x exists, right? It'll say that yeah. And another thing you can't do is use X if it hasn't been initialized. So if I were to print stuff, if I do this and run it, it's also not going to work. Well, that's one thing, but let me just do that. So what I32 is it just means it's an integer of 32-bit size, all right? And yeah, as you can see, it says X isn't initialized, so that doesn't work, all right? Cool. So the way you explicitly annotate types in Rust is you do a colon and you give it the type. Now, this is obviously very basic stuff, but when you make more complex apps, this kind of thing helps. But most of the time, the Rust compiler and the tools kind of figure it out for you. So if you want to print X out, that works and it prints out 0, right? Easy stuff. Cool. So the next thing we want to do is create a struct, right? So for those of you who don't really unfamiliar with this type of thing, a struct is essentially a collection of fields. So I'm going to put some field X in there, and I'm going to put another field, which I'm not going to use, but it's just going to be there because why not? Yep, this should compile. Okay. And the way I do that is, okay. Okay, so this is a struct. That's how you like store things in kind of an object, right? And you have this thing called an impl block or an implementation block. Oh, by the way, if you guys want to follow along or like mess around with Rust, you can just go to play.rustlang.org and you can, compile and everything in that. But you go impl my struct and you can add associated functions for that struct and you can add methods. So methods is essentially object-oriented programming, and there's also associated functions. So for example, if you want to create a quick constructor for my struct, you could do something like this. Function new, it's going to take some x. Oop, what's this? And give it back self. Self in this case is my struct, right? Because the impl block is for my struct. And you give it these things, x of 0, and another field. of 0, right? So what we want to do now is we can just do this. There we go. My struct 0, and we initialize x to my struct here. Ooh, what's this? Oh, my bad. It's new, right? So we call the new function here, pass it a 0. And the error we get here is that it doesn't implement display, which means we haven't told Rust how to display this, right? I'm not going to go into that, but how do we okay, so if you do this thing, it's going to display a debug version of it, right? And it still won't know how to do it. But the thing with the displaying debug is that you can use a derive macro to quickly do it automatically. So derive debug. What does this do? So this thing will basically take your struct code and automatically tell Rust how to display that, how to display it, right? Now, macros are important because Near uses a bunch of macros to convert the Rust code that you write to code that's going to run on the Near blockchain, right? So a lot of the implementation details are kind of hidden for you because you can just write a struct and a bunch of methods, and this macro called Near bindgen will do everything for you. But this is essentially to show you how macros work, right? Yeah, as you can see here, when you do print x, it's going to figure out that x is a struct with these two fields and print them out. Now I can do this there, and it should work. There we go. Cool. All right, so that's structs, associated functions, and variable declarations. Now, if you haven't used Rust before, that's kind of a lot all at once. So does anyone have any questions? Yeah? No, it could be anything, but it's kind of a convention to use new. There's also another thing called default, which I will get into soon, and that's used a lot in here as well. All right. Cool. Okay, so let's quickly talk about default. Now, yeah. You could do it. So you could simply do something like this. Let x, y equals my struct, and then you have to explicitly kind of put everything in. But it wouldn't let you do that because these fields aren't public, right? So if you wanted to do that, you would have to make all of it public as well, which is fine, and it's commonly done. But having this sort of thing is just convenient if you wanted to write structs like this. I'm going to quickly talk about default. There's this thing called traits in Rust, which I don't really want to get into because it's kind of complicated. But essentially, what it does is it abstracts away some common behavior, right? So if something has an implementation of default, when you call the default function on that struct, you get a default implementation, right? So if I implement default for my struct, and then just say that it's equal to my struct, and then both of them set to 0. If I print it here, it should just get the default thing for me because it knows that it's implemented, right? Nice. So what this bit of code is doing is it's saying, this is how you make a default my struct. And this is important because you use that kind of code in Near when you're constructing default like states for contracts and so on. Okay. Cool. Yeah. The colon question mark. Yeah. So when you're displaying stuff in Rust, this thing means display it. Colon question mark means display it in debug form. But yeah, that's, yeah. So it'll just display a debug, a format for use for debugging, right? Yeah, basically that. Cool. Okay, now I'm quickly going to talk about methods, which you can implement for structs as well. So let's create a method called add, right? So what add is going to do is just add the two x's together. I'm going to get rid of another field because we don't need it. And I kind of just used it there so that it's understood that you can put multiple things in there. So we'll get rid of all of this. Okay, nice. So what we want to do is we want to take self, another of type self, and we want to give back a new thing, right? So what we will be doing is by struct, the x that we put in there is going to be self.x plus other.x. So let's test this out. Let's make this 3. Cool. So if I run this, it's going to give me 5, right? So let's quickly go into what this actually means. Now, when you do self here, you can use the x.add, for example. You can use that notation to access different methods. So it's not an associated function for the struct. It's a method that you call on the struct. Now, what does this AND symbol mean? This means that you're going to borrow it immutably, right? I don't want to get into the intricacies of the Rust borrow checking system, but what this basically means is that you don't take ownership of it because basically you have read-only access to the struct. You can't write to it. It doesn't get destroyed at the end of the function, but you can read from it, right? Because in this case, I'm just accessing X. I'm not doing anything else with it. So if I do an immutable, ooh, what happened there? If I do an immutable function like this in near, what that's going to translate to is a public read-only function. Now, you can use macros and things like that to customize it, but that's the default behavior. Any questions? Great. And then I'm going to do another thing called mutable add. So what mutable add does is it'll take a mutable reference to self and then another. And then instead of returning it, it's going to modify the thing itself, right? So in that case, we can do self.x plus equals other.x. And notice how we're doing the AND symbol on other as well. This means we're getting read-only access to other as well. Yeah, cool. So let's do x.mutable add z. And then if we did this, it should give us, ooh, what happened there? Ah, yes. So that and this. Okay, so this error means that you cannot borrow x as mutable. So in Rust, by default, everything is immutable. So we want to mutate x inside this function, right? So we have to declare that x is a mutable thing. So how you do that is you go here and do let mute x, right? Cool, everything works. The first time you do x, it's equal to 2. Then when you do the mutable add, it's equal to 7 because z is 5, right? Yeah, nice. What would probably help is if I did this, then. All right, so let's quickly recap. What have I touched on like up till now? this one. Right. So we don't need to put a return type because it returns nothing, right? It's a void function, so you don't need to put a return type. But yeah, so to quickly recap, we've figured out how to declare variables which are mutable by default. You use the mute keyword to make them mutable. We've talked about structs. We've talked about how to declare associated functions, methods, which are immutable and mutable. And we've talked about implementing traits. So these can be any traits, but in this case, I implemented the default trait, which simply means how do you construct a default implementation? Any questions about Rust stuff? Any? Yeah. Yeah. The compiler will just say, no, you can't do that because it's not supposed to be mutable. So that's kind of an additional safety check that you get in Rust, which prevents a bunch of errors by accidentally modifying things. Anyone else? Great. As a quick thing, if you don't do the AND here, what happens is that the function takes ownership and the object kind of gets destroyed at the end of the function. I won't go into the details of that, but that's probably something you need to know because it's a common like error that comes up. But yeah, that is the basic Rust stuff that we wanted to talk about today. And let's go back here. Cool. And yeah, so now that you have some idea of what Rust code looks like and how you can use it and declare structs and so on, let's talk about the structure of a Near app, right? So you have your users of the Near blockchain, all of whom have wallets, right? So if I have a wallet, I can interact with Near dApps or like apps that use the Near blockchain. And I cannot do so without a wallet because it's kind of like an account. We interact with the wallets using Near API.js and Near Wallet Selector. These are JavaScript libraries which are provided by Near to us, which we use on the front end, right? So the front end is the web side of things where you use JavaScript like TypeScript, so on, HTML, CSS. We use those libraries to interact with the wallet, right? So with those libraries, what we do is we call the public methods on our contracts, which is going to be very similar to what I showed you just now, which is just methods on a Rust struct. So what we do is we put in the name of the method using those libraries, and then using that, we can modify the state of our smart contract, right? So in our Rust code, what you essentially have is a struct, which contains the state of your smart contract, and your methods are going to be implementations on that contract struct. That's essentially how it works. The way Near has made it is very simple to understand once you know a bit of Rust. But yeah. Cool. So like I said, how does our Rust code map onto Near? The contract state is stored in a struct. Contract methods are just public implement methods. And there's this macro called Near bindgen, which is going to generate the needed code to convert your Rust code that runs on Near, right? So this is exactly like the debug thing that I showed you earlier. If you go up here, this thing tells you, take my struct and automatically figure out how to, do the debug display. And Near bindgen is a similar macro that's provided to us by Near, which takes all the code that you write and says, okay, convert this into something that's going to run on Near. So it hides all the network stuff and all of that. You don't have to worry about any of that stuff, right? Any questions till now? All right. Ooh. Moving on. So let's quickly talk about Rust tooling. If you've never used Rust before, you install it using RustUp, which manages different versions of Rust toolchains. So using RustUp, you can switch between different editions of Rust and different versions which are released on different dates and so on. Rust package manager is Cargo. Cargo is absolutely fantastic, and libraries are called crates. So how you would do dependencies and things like that, you have this file called cargo toml, and you just add the library you want to use and the version, and Cargo will simply download it and install it and do all of that stuff for you. So it's very easy to use, and that's one of the reasons that Rust is so great. Yeah, now I'm going to do some live coding. What we're going to do now is go on this snapshot of the kit pod, which should work there. Okay, that did not work. Cool. All right, let me just get this thing set up so you guys can follow along. But what this is going to be is, I've taken the Hello Near example and removed the contract code, and together we're going to rewrite that stuff so I can explain to you along the way what each thing does and how it works. Yeah, the link is. Yeah. Okay. Sure. No. All right. Yeah. So until that works, I think let's quickly go over the structure, which we kind of went through last time, but let's do it again. So this is what a Near project looks like. If you use Create Near app, you have the front end, which is here. In this case, we're not using a JavaScript framework, so it's just vanilla JavaScript, HTML, and CSS. You have integration tests. You have a package JSON, which has scripts that you can run. And this is just Gitpod stuff, which you would need if you're using Gitpod. And in there is your Rust project. So that's where your contract development would actually go. So this is what I was telling you about earlier with Cargo Toml. You put in Near SDK and the version, and whenever you run it, so if you say cargo run or cargo install, a cargo will do all of that stuff for you. Okay. Okay, nice. This one worked. Oh, that is weird. Oh. Maybe. Can someone try this link and let me know if it works? Yeah. Doesn't work. Does it say operation not permitted or something like that? Okay. All right. I think I'm just gonna continue, but basically this is the Hello Near example, and I've kind of removed everything, so we're gonna be coding this out ourselves, right? Cool. So the first thing we want is we want a struct to represent our contract state. If we go over here, this app is running already. But the contract bit just doesn't work, right? It says the contract says blank because like we haven't implemented the contract yet. So this is the front end, and I can sign in, but it won't really do anything. Cool. So what this is supposed to do is it's going to say the contract says and give us a greeting, and we can change the greeting, right? And it'll read the greeting from the blockchain, so the near testnet, and we can change the greeting. And when we do that, it'll write to the near testnet as well. Cool. So the first thing we need is a struct to represent our contract state, right? So let's quickly, can everyone see this, by the way? Can you guys at the back, can you guys see it? Cool. Thumbs up, thumbs down. All right. Cool. I'm just going to make it slightly bigger anyway. Okay. Is that fine? Okay, cool. So we do struct, and we can just call this contract. And so there's one field that we're going to be changing, which is just the greeting. So we can just do struct contract. It has a field called greeting of type string. And we want to derive a bunch of things, right? The first is the thing that I said before, which is near bind gen. Okay, what this will do is it'll take your Rust struct and convert it into code that kind of tells Near that this is a contract state and how to kind of use that, right? Okay. Cool. There's other stuff we need to do, which is derive. And we need to derive Bosch serialize and Bosch deserialize. What does that mean? So what this means is Bosch is just an algorithm for serialization and deserialization. So this means how do you convert your struct and the data in it into a compact binary format? Now, alternatives are something like JSON, which you use to send data up and down. But the reason we use Bosch is because it's a very compact binary format. Then we can send larger amounts of data with using less resources, which is a good thing, and we want that. But yeah, that's what the code for our contract structs looks like. I think that's fairly straightforward. Does anyone have questions? No? Yeah? Okay, so it depends on what you're using the struct for, right? If it's internal to your Rust code and it's not being sent around. So the serialize, deserialize is for stuff that's being sent around. The near bindgen kind of just tells it that it's a contract that can be used. So if it's internal to your Rust code and you don't really want to use it elsewhere, then I wouldn't think you need to do that. But yeah. Okay, so now we just want to have a default message so that when our app starts up, it's going to display that, right? So just the exact same way I did earlier, we're going to implement default. So function default, which gives back self. And this is going to return a self of greeting. And all right, let's make this a constant so that we can use it elsewhere in our code. So let's do const default message. String. Does anyone have an idea for a default message? Shout it out. I'll just use hello world. Very creative. Nice. Thanks, guys. Okay. Let's just use hello world. Default message to string. Ignore this bit. This is like a Rust subtlety. Essentially, there's two different types of strings. There's string slices and there's own strings. And what we're doing is converting between the two. But yeah, as you get more into Rust, you'll kind of figure out the subtleties of that. But I want you to just ignore this for now and focus on the bigger picture. Okay, so the next thing we want to do is implement the contract structure, right? So what I mean by that is what methods are available for users to call on the contract, how you can read to it, read from it, how you can write to it. So this is impl contract. And we want two functions, a public function that's get greeting that returns a string. This will take self. And a function that's set new greeting. I think it was called that, set greeting. Now, these names are important because they need to kind of match up on the other side as well.
The reason that not to remove the permission issues.
Okay.
This new one will have the full code. I don't know when you spare that.
Yeah, that's fine. Let me just refresh that. Sorry. Okay. Okay, nice. Okay, so this thing is, yeah, if you guys use this link, what you'll get is the full code, which I'm going to be implementing, right? And I'm going to be writing that out and showing it to you guys. But yeah. Once everyone's copied that down, just give me a thumbs up and I'll move on. Everyone got it? Got it? Cool. We'll move on. All right, perfect. Okay. So yeah, so like I was saying, let's quickly recap. We have this struct which is our contract state. This is near bindgen, which tells Rust to create more code that allows near to kind of use it. Serialize and deserialize, which tells which derives things on how to convert our struct into compact format, which can be put over the network, and a default implementation for our struct, right? So now we have the public methods, which is get greeting and set greeting. Cool. Okay, no, this needs to take greeting as well. Just a string. Okay. Now, as I was saying, the names are kind of important here because it needs to match up on the front end, right? So when you're calling the function on the front end, it needs to be the same name because otherwise it just won't work. Okay, so this is fairly simple. If you want to get greeting, you can just do self.greeting.clone. The reason we are cloning it is because we want to make a new copy of the string to send over. And the other thing is set greeting, which is we do self.greeting equals greeting, and you can also do a log and say that this has been done. Yeah, so what this does is it's going to log that this new greeting was saved, and then it's going to do self.greeting equals greeting, which is going to mutate it, right? Note that in this example, it's kind of trivial, but if you're working with larger amounts of data, you want to minimize reading and writing from contract state as much as you can. So because that kind of costs you money because of the way the system works with the blockchain and so on. Now you can do tests and stuff, but I think we're running slightly short of time, so I'm not going to go into that right now. But yeah, cool. Now let's try rerunning the app. See if this works. Oh, wait, I forgot something. So we have to do near bindgen, right? Because otherwise, near is not going to know that this is meant to be used in the blockchain, right? Because otherwise, it's just a random impl, which is Rust code. And that's why it doesn't work right now. So I have to do that again with the near bindgen. Should work. Okay, nice. So as you can see here, our default thing was hello world, which is set by default. And it says the contract says hello world. And we can change the greeting to, I don't know, hello. And then if you save that, it's going to change, I think, should. Yeah, that works, right? So what have we done so far? We've created a struct that captures the blockchain state. We've created two methods on the struct that read and write from this contract, right? So with this Naman's whole example from last week about how it works as a database, you can kind of see how that works, right? And you can add more application logic on top of that to create more complex applications. But yeah, now let's quickly go over, I think, front end. If you want to, yeah, quickly go over front end.
Okay, perfect. That can be split. Where are we coding? We're coding here.
It's the same one. It's liberalized.
This one.
Yeah, yeah.
Perfect. All right. So I'll be walking through the front end.
We haven't uploaded yet. We uploaded once so far.
Okay, so in Rust, most things are expressions. So if you have a block and the last thing, basically the last thing is the return thing, if you have a block, right? And you don't have the semicolon because it just expects it to be the return expression.
Perfect. So yeah, thank you, Ashwin, for taking that sort of part of the course. Just like a one recap, I'd say on Rust is you might notice there's more compiler errors in Rust. And the general reason for this is because the purpose of Rust as a language is to take away runtime issues into compile time. So when you're writing a contract and you make a typo somewhere, let's say I'm trying to add two numbers together, by sort of add different numbers or something goes wrong with the typing, you spot that compile time rather than runtime, so you don't end up losing lots of money if you deploy the contract on the mainnet. So what I'll be doing today is walking through the front end, which is whenever I sort of click this link and come on, click, yeah. Whenever I click this link, I see all this stuff happening here. Like half of it is the backend, which is how it executes on the contract, but the other half is how do you actually write the front end that connects to your wallet and gets the details of your wallet, and if you're dealing with the money, how do you sort of see that money in your wallet? I'll just show you the workflow of the front end quickly, and then we look at the code behind it and see how that works. I'm not sure if there's time to sort of copy it as well, but we can, it's not too complicated, so we can just walk through it. We sign in here, and we get this little sort of sign in window. And I mean, you get a testnet wallet because it's completely free and it's good to have. Then it, we get some sort of standard stuff. This is actually handled by the testnet URL, not by our web page, so we don't have to worry about actually creating the UI for this. Our UI is just whenever we come back to this sort of endpoint here, this is our UI. Looking at this code, where's this handled? So a good thing to do whenever you're coding is just like make it very clear where your code is. So this is going to be in front end, like so. And once again, like a quick reminder on how a front end looks like, you have a package.json which specifies all the scripts, which are essentially all the things you can do to start this front end. It's a bit more limited than this package.json because you actually want to run the front end with the back end in this environment. And then you have your web page, which is index.html right here. And you'll see straight away once this is up that there's a bunch of sort of signed out, signed in sort of keywords. And this is really important because we have to make sure that you have a wallet connected, because you can't run any code if you don't have a wallet connected. And you might notice that there's two chunks of code, like two chunks of text. And you're like, well, I should not be able to see some of these chunks. And that's handled by the JS logic, which prevents you from seeing code that's only visible when you've logged in. This is very standard sort of website stuff. You keep everything in index.js. You use a block or a div to hide some stuff when you don't want it to be shown, and you change the visibility of that when you do want it to be shown. And you use IDs to just pick which block at each time. So for example, you can see this display is none, and this is really important because you don't want the code showing what's happening once you're logged in. Whereas that's just signed up flow, signed in flow. Okay, they're both none. I guess this is handled in index.js, where it sets one of the visibilities. Here, right here. So we can see that it sets the visibilities alternately. Here. So I don't use Mac. They use these two lines here, set the visibilities. But let's sort of follow the code through and see what's happening. Here we so say when the page loads up, I want an asynchronous function. So what does it mean to be an asynchronous function? It's whenever we write code, we often assume there's like a sequential operation to the functions. But sometimes you might want a function to call something that you don't know when it's going to come back, right? It might take a long time to come back. It might take lots of long time to come back. And you just say, I want this to come back, and I have a promise that it will come back. So you wrap it in an async, which says, this is the one thing that's going to come back, but it might take some time to come back. And then anything that's an await is like, this is the key sort of word or the key parameter that is going to take some time to come back. And let's look at what that is, wallet.startup. So whenever you're using one of these things, just click on the method, like so. And you can see that this method opens up in near wallet. So near wallet is actually the interface or the helper file that allows us to connect to our wallet. And it provides us with a bunch of methods called the wallet selector and so on. So it's just like how we pick which wallet we're using. If that's a Ledger, if that's a testnet wallet. And you can see this here is wrapped in a class, basically, the wallet selector, the wallet and network, and so on. A lot of this boilerplate code, you can pretty much copy and paste it into your own environment. And I would probably copy and paste it, save time on connecting with wallets. Like you don't have to copy this stuff. The logic is really in the smart contract stuff. What's really happening in this part? So when the website's loaded up, we call startup. And once again, this is wrapped in async because the function that called it was wrapped in async. And this is the part we're waiting for. We call this setup wallet selector, which is actually the method that's given to us in our sort of library that Ashwin referred to. And this allows us to pick the wallet we want to use. And then we set up, if it's a ledger, we set up a ledger. If it's just a wallet, we use a set up near wallet. And these are both sort of libraries given to us. Generally speaking, this is the one that's more often used, the set up my near wallet. Ledgers are much more rare. Once again, when we call this is an await, right? So we have to wait for this to collect and connect to our wallet. Once this is connected, then we get a return value, which is like true or false, right? So the Boolean, and that's the reason we've had this await, because it wraps this type in a promise. And when a promise returns, we know what the value of this is going to be. If we are signed in, we can sort of get the account information, get the state. So Ashwin referred to the state quite a lot. And the state is just a representation of this database we referred to last week, which is what the wallet is representing at a certain time. And this is basically the account ID and the wallet itself. And we return true. And if you look back at index.js, we can see that once it returns true, we go into sign in flow and we swap around the visibilities of our two blocks of information. That's that. And I guess let's assume we're signed in now, right? So we've done our sign in and we're signed in, and this part has been executed. Now we're looking at what fetch greeting is, and this is kind of self-explanatory, but fetch greeting is another asynchronous function, which actually calls a contract on the chain and asks it to give us a greeting that's stored on the contract on the chain. And what we do is we look at the wallet, we look at the method on this, and the method is get greeting. So if you remember, we had this get greeting method here, and it's really important. This is where the names sync up, because your front end might be calling a method that doesn't exist on the contract. And you need to make sure that whatever's on the contract can be accessed from the front end. So generally speaking, you often like think about what the contract wants to implement, and then you wrap around some front end functionality for that. So we've got this get greeting method which returns the sort of the message in our struct, like so. And we also have a set greeting method. So if you go back to our index.js, where we have called this get greeting right here, we can call it, wait for it to return from the smart contract, and then actually display the content on our sort of web page, like where we had, if you remember, we had something, was it this one? One of these tabs refers to like the front end. I might just open it again, that might be easier. Okay, this one. Okay, they all refer to the front end, and you see that this hello part is actually straight from the contract, lifted up from there, and this is wrapped in this functionality here, where we get this current greeting, and we pass it in as the inner text parameter for this sort of DOM, which is that sort of UI part of our website, in this Lambda function, and that's how we do this fetching the greeting. There's also this element of setting the greeting, which is happening up here. And what's happening in the setting the greeting is very similarly, we're calling this method on our wallet. So the wallet is like how we access our smart contract, and we can call the method set greeting with this time parameters. So last time we didn't have any arguments because we were just calling. Yep. Sure. So these are both what's it called? Both parameters of our document here. This is data behavior. And if you look at that in our HTML, which is here, and we can find where this is. Essentially, there's both of these we need to change because both values actually are used for rendering this change in the wording. You can look into this here. Let me try to find it. then I can go to here. Just for the printing and greeting. Data behavior greeting. Okay, so here we are. This is our span class. So when we look at the CSS for this, or we can look at this greeting, we can see that we actually have to update several parts of this. And because it updates several parts of it, that's why you have to do both the inner class and the value. Otherwise, you just do one of them. And this is more like a rendering choice than it is actually like a mandatory thing. Like if you use a different way to do it, you don't have to use both of them. This is just the choice of how they've decided to render this. So that's why we did that sort of setting both of them. If we go back to where we were setting this up here, so the difference here is now we have to actually pass in an argument to our contract, which is the new sort of greeting we want. And we have to specify that in this function here, like in this part here. And make sure that we pass in the right type as well. This is where it can get messy. Like you might start trying to pass in like different types and make like sort of mess up with the contract. And this is where it's really important that you have a good contract that's nicely typed, because it means that you can't pass in stuff that might break the contract. For example, I don't want to pass in a struct here. I don't want to pass in a Boolean here. I want to pass in a string. And it's very important that we know the contract upon which we are passing these arguments. That's why we have this sort of contract address, which is this thing here. This is a process, so environment variable, and this never changes. I think that's my sort of skim through the front end. There isn't like the front end is always much more code, but the code is implementing the functionality of the back end. What usually happens is in future weeks, the front end will remain quite minimal. Like it won't change size in terms of the code base, but the back end will get much more complicated. So this front end you can almost take as a granted, and you'll see this coming through next week and the week after, because it's just signing into our wallet. But the backend code will change, and we'll add in more functionality to support so donation, which is like changing different wallets amounts, or any other sort of more complicated stuff. But the principles will continue as they have been today. Any questions? Any requests? Like, what would you want this to change for next week, if anything? So you want us to code whilst we?
Yeah, see our changes.
Well, like live share.
Yeah, live share.
Okay. Yeah, we can do that. I think because you can open this in VS Code.
With 50 people.
I'm not sure if everyone wants that. Is it like something that everyone would want, or just some people would want it? If not, we could just. Yeah.
Okay, that's something to think about. Any other requests?
Yeah, it'll be on the. We'll change the links on the presentation, but it should be on there.
Is that all for the presentation?
On yeah, on the like thing.
And
That's everything from our side.
right, okay. Let's give that a applause. Alright, so thanks everyone for coming. And I know that pizza came just now, just before it started. So we actually did order a few more. So it'll be coming like 5-10 minutes. If you guys want to stick around to you haven't had your fill yet. But next time, please do sign up on Eventbrite so that we know whether you're coming. So we don't order like for 25 people, because I don't think it is 25 people. There's a lot more than expected. So again, thanks everyone for coming, and hope to see you guys next week. Yeah. But stay around if you want to chat or have pizza.
We do, okay.
No problem.
If there's any way you can order some gluten-free pizza next time.
Oh yeah, sure, of course, of course. Vegan?
Gluten-free.
Yeah, sure, no problem. We will.
Thank you so much.
Yeah, sure.
So it's gonna be on Tuesday, yeah?
Yeah, next Tuesday.
It was very interesting.
Oh, thanks. Thank you. See you.
So this happened with some links. It might be something to do with the fact that like this maybe it's something to do with the fact that but like if you go on the near documentation,
Where's it come?
it's the same thing, and you can open get from that. What I did was actually open. Only if you're sending notifications. Yeah, so, and the plan is just to be on that as well. And we will be getting the data at some point. I think we might do an email thing or on next week's session.